Hello everyone. In today's session, I'm going to discuss about the bitwise operator. So, what is bitwise operator? As we know, operator is a kind of symbol which allow to perform some specific kind of work related with that symbol only. So, bitwise operator is uh, a category of your operator which allow to perform some specific task with their subcategories. So, what is the work of the bitwise operator? Well, bitwise operator allow to perform on the beats only. It means when operation performed between the beats is known as bitwise operator. So what is beats here? Here, if we take an example of the binary number is a collection of bits. It's not defined as an individual bit. So if we present the number as 0 or as 1, is represented as a beat only. So beat will be presented by the 0 or 1 only. And bitwise operator allow to perform the work between the beats, that is 0 or 1. So bitwise operator has different category. Let me check them one by one. So the first one is AND operator. AND operator will be presented by the ampersand sign in Python. If we talk about the Python, the bitwise AND operator uh, is always defined by the symbol of ampersand sign, but if we talk about the logical operator, it will be presented by AND itself. So what is AND operator here? And in bitwise AND operator, we need to be perform the operation with the decimal value. It means we can perform the operation with the numerical data, but your translator will perform their operation after the conversion of your decimal value into its equivalent binary data. So let's check the values of decimal to binary first before start the work of AND operator, bitwise AND operator. Suppose both are the numbers presented in the decimal form. So what is the binary equivalent of 4 and the binary equivalent of 5? Uh, for the conversion of decimal to binary, we have to be convert it from the base of the binary, which is 2. So just convert it from the base of the binary and collect all the remainder. So if you use 2 into 2, it will be presented as 0. Then again put 2, 1. So what will be the quotient here? That is 0. So this is a binary of 4. This is the binary of 4 here. Now as similar, if we want to find the binary of 5, we have to be follow the same step or the same process. So just use the base of the binary. So and calculate, find the value of after the calculation. So 2 into 2 equals to 4, so it returns the value as 1. Again 2 into 1, that is 0. So what will be the output in the binary? That is 101. So the value of 4 in binary is 100 and the value of 5 in binary is 100. Now what is an AND operator or and bitwise operator in Python? According to the rule of the AND operator in Python, if both operands are 1, it will present the result as 1, otherwise it will present the result as 0. So let calculate both binary digit with each other using ampersand sign, sorry. Now if both operands are 1, so here 1 and 1 both are 1, so it will present the result as 1, otherwise it will present the result as 0. So here it will present the result as 0 and again 0. So as we know, decimal of 100 equals to 4. So the output will be 4. Let's check the output of 4 and 5 in the Python cell. The compiler of the Python will calculate your data in such a way. So let me check the value of your data in the Python cell first. So what will be the input? That is 4 ampersand sign to represent the AND operator, and then 5. It will present the output as 4. So here the process which will perform by your translator in as similar way uh, which performed by us here. Now the next operator is OR operator. What is OR operator? Bitwise OR operator in Python. So as like AND, bitwise AND operator, OR operator also allow to perform the operation if and returns the value accordingly. But according to the rule of OR operator, if both operands are 0, it will present the output as 0. Otherwise, it will present the output as 1. So this is the rule of OR operator which we have to be remember when we work on or operate with the OR operator. So let's check the behavior or OR operator with an example of the manual tracing. So let's check the same example, like as we know the binary of 4 is 1 0 0, and the binary of 5 is 1 0 1. So if we use the OR operator between them, what will be the output? As we know, if both operands are 0, the output will be 0, otherwise the output will be 1. So here one operand is 0 and another one is 1, so it will present the output as 1. Again both operands are 0, so it will present the output as 0. Again both both operands are 1, so it will present the result as 1. So the 4 bitwise or 5 equals to 101, which is a value of 5. So let's check the value of 4 or 5 using the Python cell. 4 or 5. So here we can see it will present the output as 5. So this is the working condition of your translator which allow to perform the operation by the bitwise operator in such a manner only. Now the next one is XOR operator, bitwise XOR operator, which is defined by the caret sign or the cap sign of your keyboard. So what is the work of XOR operator and how it will represent the value? So according to XOR operator or according to the rule of XOR operator, if both operands are same, it will be presented either as 0 or as 1. So but both must be same. So if both operands are same, the output will be 0, otherwise the output will be 1. I repeat, if both operands are same, either it will be presented as 0 or as 1, but both must be same, the output will be 0, otherwise the output will be 1. So let's check with the example. Suppose we use the value 1 0 0 1, again 1 1 0 0. So in that case, uh, if we use the XOR operator, so if both operand will be same, if both operand will be same, it means here the first operand consists 1 and the next one consists 0, so the both operands are different, so it will be presented the result as 1. Again both operands are same, so it will present the result as 0. Again both operands are different, so it will present the result as 1. Again both operands are same, that is the first operand consists 1 and the second operand also consists 1, so it will present the result as 0. So this is the behavior of your XOR operator, bitwise XOR operator. So now we can check the result. So let me convert that binary into its equivalent decimal. So the value is 0, 1, 2 and then 3. It means 8, 2 power power 3 equals to 8 here, and again 2 power power 1, sorry, 2 power power 0, that is 1. So it will be presented as 9. Now the next one is 0, 1, 2, 3. It means 8 plus 4. Sorry, it means 8 plus 4 equals to 12. So these both are the input and this is the output. So let's check the output also. 0, 1, 2, 3. So 1 and then 8. Sorry, it's 4, not 8. Equals to 5. So let's check the example of OR operator first. So let's use the example in the Python cell. So the value is 9. What is the value? 9 and 12. So use the XOR and then 12. What will be the output here? We got 5. So let's check. So this is the process which performed by your translator using XOR operator. The next one is bitwise not operator. Bitwise not operator always treated your value or the given data as the ones complement value. It means it always invert the given value. Suppose if we put 4, that is the value of 100, so it will treated that value before the calculation in the invert order. It means it will treated that value as 011, which is defined as a complement. So let's check it first. So suppose if we want to, if we use tilde, that is the sign of not operator, and 4, so here it treated 4 with its complement or with its one's complement. Suppose the binary of 4, as we know the binary of 4 is 100, so the not operator will treated that 100 as 0 1 1. But one more thing we must be remember in the not operator is that when we use the number in the in with the not operator, the binary digit will be treated with the 4 bit instead of the 3 bit. The minimum value must be treated with the 4 bit. So by default, if we put the 4, or if we put any number with the not operator, it will be treated with the 4 different digits. So here automatically a 0 will present with that number. uh, as we know, if we put the 0 in the left side of the number will be not affected with that 0. So by default it will be treated in this form. Now if we talk about the tilde operator or the not operator, by default it treated your number with the invert order. It means if we use the number as 100, the not 4 means it will be presented as 1 0 1 and 1. So here that 0 is represented as the signed bit. Signed bit means if the value, the left side of your value will be presented by 0, it means the number is in the positive value. If the value will be presented by 1, it will be defined as the negative value. So this is the inverse or the ones complement of your 4, which will be treated by your system when you use the not operator with the data. But in that case, if we want to find the value of the not 4, we have to be use the 2's complement. It means here it just treated your data in the with the ones complement, which we must be utilize with plus one operation. So in that case it put the addition of 1 with your data to find the value of the not 4. In that case it will be presented the value by the operation of this equation. So here we can say, if we use not operator with any digit, by default it will be treated by the ones complement and converted before the execution, and again it will be added by 1. So what will be the output? It will be presented as 0 plus 1, that is 1, again 0, again 0. So here we can see, now the value of 4 is defined as the last value of the 4 is represented as 0, so it will be converted by that. It will be again converted from the 0 to 1, and now it will be presented as 1 here. So in that case the 1 will be presented as minus, as we know it will invert the value, so it will be presented as minus and return the result with the value that is 101, which is 5 actually, and 1 presented your minus sign, so it will be presented as minus 1. So let's check the value first. Now here we put tilde 4 will presented the value as minus 5. Now the next one is I am going to present suppose tilde 7 or not operator 7. What will be the output? According to me, let's check the output first before the execution. So the binary of the 7 is what? The binary of the 7 is 1, 0, 1, 1, 1, sorry, 1, 1, 1. So here this is the if we use tilde 7, so it treated as 0, 0, 0, and if according, because the exact value of 7 is 1, 1, 1, and when we put tilde it will be treated as 0, 0, 0. So here just put the 1 with that 7. So when you put 1 with that 7, which is defined as a 2's complement, so here 1 plus 1 equals to 10, carry 1, again 1 plus 1 equals to 10, carry 1, again 1 plus 1 equals to 10. So as we know, if we use the tilde operator, the most significant bit will be presented as 1. So here it will be presented as the positive value. So the next value is always will be presented as the negative value. In that case, the output will be presented as 1000. So let's check the output first. So here we can see that the output of 10000 is 8. So it will be presented as minus 8. So this is the performance of your bitwise not operator, which will perform the data in this way. The next one is right shift and left shift operator. So let's check the right shift and left shift operator, which also allow to work with the beats of data instead of the decimal values. The first one is the right shift operator. So what is right shift operator? It just shift the bit value one by one according to the given equation. So right shift operator, in right shift operator value move towards right. So suppose here we have a value, suppose 1 0 1 0, which is 10 actually. So if suppose we use 10 right shift 2. So in that case, uh, the value moved towards right uh, in this direction. So and a new beat will be added on the left of the value. So if it moved towards right, the beat will be shifted at 2 times. If we use 10 less right shift 2, in that case the data or the beat must be moved at 2 times, and new beat introduced that will be always be presented as 0. So here if it moves in the right side, again a new bit will be added here. So in that case a new bit will be added or introduced here, and the old bit shift towards right, so it will be removed from the list. Again here it will be shifted at 2 times, so again a new bit introduced here, and a previous bit will be removed from this place. In that case the total value of 1010 equals to 10, so it will be presented as 10, which is 10. So let's check the right shift operator in 10. right shift sorry right shift 2. So what will be the output? The output will be 2, which is 10 in the binary equivalent. So this is the work of the right shift. Now the left shift, it just opposite from the left shift is just opposite from the right shift. So it will be added the new bit, the bit will shifted towards the left. In that case, suppose we have a number 10. The binary of 10 is 1010, as we know. So suppose we use 10 left shift 2. So in that case the beat will be shifted towards right, sorry, towards left. So it will be shifted towards left, and a new beat will be added here. So in that case a new beat will be added, 1 bit and 2 bit will be added on the right side. Now what will be the output of if 2 bit added here? So let's check the output. That is 0, 1, 2. I have to be find the decimal first. 3, 4, 5. We have to be calculate the power of 2. So 2 per power 5 equals to 32, plus we have to be remove the 0 value first. 0, 0, 0, because as we know the multiplication of 0 is always 0, and 2 per power 3 equals to 8. So what will be the output? 40. Let's check the value on the Python cell. So 32, and then left shift, sorry, not 32, 10, left shift 2, 40. So here is the work of your left shift and right shift operator. When we use the left shift and right shift operator, it will add or decrease 2 bit left or 2 bit right on your value. So this is the format of a bitwise operator. In the next session we will discuss about the next operator, that is the assignment operator, identity operator, and the membership operator. Thank you.